Alrighty, as promised, we're doing a second video here explaining the second half of practice quiz 8.1 to 8.2. Jumping right in, we are going to look at another problem where they ask us to add or subtract. And it's as simple as distributing the minus sign. That minus sign is going to be a minus 6x instead of a positive 6x. That's going to change that to a plus x to the third. It's going to change that to a minus 6x to the fifth. And the first set of parentheses, there's nothing to distribute, so we could pretty much just rewrite it without parentheses. That'll be a x to the fifth plus x to the third plus 1. And then we have to combine like terms out of all of these terms. Let's begin with the highest exponent term. Highest exponent term is x to the fifth, and let's combine it with any other x to the fifths, which we have a minus 6x to the fifth. So there's really a 1 x to the fifth take away 6x to the fifth. That will be the answer, negative 5x to the fifth. And then you move on to the next highest exponent. Is there a power of 4 after the 5? No, there's no power of 4. Is there a power of 3? Yes, there is. I'm going to combine this positive x to the power of 3 with that positive x to the power of 3, and that'll give me a total of 2 of those x to the powers of 3. And then moving on, are there any x squares? No, there's not. Is there any x's? Yes, there is. There's an x right there. And I could combine this negative 6x with nothing, right? There are no other x's, so you're just going to bring that down, minus 6x. And at the very end, we're just going to put this plus 1, which there is no other number to add it to, so just put plus 1 at the very end. And here's your final answer. I know it's colorful, but you got to type that in exactly the way it is. And if you look at the answer right there, it is exactly that. Okay, so hopefully you guys are able to type that in without making mistakes. Let's move on. Number 15. On this question, they're asking us to classify this polynomial, but it's really simple to, because the first name is based on the degree, the highest exponent 4. So out of all these words, this is a drag and drop. So the degree 4, it's not linear, it's not quadratic, it's not cubic, it is quartic. So what you're going to have to do on your test is take the quartic and move it up here, right? Quartic, last name, there's only one term there, so that's obviously monomial. So all you got to do is take that monomial, put it right there, and voila, you will get full credit. Let's move on. Another almost identical question where you drag and drop. Obviously, the power of 2, power of 1 is linear, power of 2 is quadratic, power of 3 is cubic, power of 4 is quartic, power of 2 is quadratic. So out of all these words, you're going to pick quadratic, and you're going to move it up to that first name position. And then you do have 1, 2 terms. That is a binomial. So you're going to select this word, binomial, and you're going to drag and drop it right there, and that'll give you full credit. That is a quadratic binomial. Let's move on. We are on number 17, and they're asking us to simplify the square root of 35. So what we need to know is the perfect square numbers list, right? So you could write that down anytime you want. 1 times 1 is 1, 2 times 2 is 4, 3 times 3, 4 times 4, 5 times 5, 6 times 6, 7 times 7, and so on, right? The idea is that the square root of any of these numbers is a nice perfect answer. So if I say what's the square root of 9, the answer is 3. If I say what's the square root of 36, the answer is 6. So it's pretty clear we want a perfect square number in here, okay? So if we don't have a perfect square number, we attempt to rewrite it with multiplication to get a perfect square number. So like, will 4 times something give you 35? No, it won't work. Will 9 times something give you 35? No, it won't work. 16 times something? No. 25 times something? No. So you cannot rewrite it with multiplication to get a perfect square number. So simplify the square root of 35. That is exactly the same thing, square root of 35. Now you might be thinking, wait, you could break it down to 7 times 5. Yeah, but 7 is not up here. It's not a perfect square number. 5 is not a perfect square number. So that is totally pointless, right? If I'm asking you to simplify this, that's already simple. There's no way you could simplify it further. Okay, so that's the answer for number 17. Likewise, if I were to say, what's the square root of 7? Simplify square root of 7. That is the square root of 7. If I say simplify the square root of 13, well, that's the square root of 13, right? If I were to say simplify the square root of 14, like, yeah, you could rewrite that as 2 times 7, but 2 is not a perfect square, 7 is not a perfect square, so you would just leave it as a square root of 14. I hope this makes sense. Let's move on. So we have another simplifying radicals problem. We're going to have a lot of them actually. So we want to simplify the square root of 16, and the square root of 16 is 4, right? 16 is a perfect square number. If you look at your perfect square number list, 16 is up there. 4 times 4 is 16. So the square root, remember the square root means what number times itself will give you this answer, and that would be 4. So this right here will be 4, and you do have an 8 in front, and that's not an 84, that's an 8 times 4, which will give you the answer 32. If we check our answer right here, that's exactly what you need to type in to get full credit, 32. Alrighty, let's move on. Again, we're simplifying a radical, and right here we do have a negative inside the square root, which we know produces an imaginary value. A thing that we need to know is that the square root of -1, that actually produces the imaginary variable I. So this negative sign is going to come out as an I. What you do is you rewrite it, right? You have a -1 times 20 instead of, you split the root like so. Work with the square root of 20. The square root of 20 actually becomes, see, 20 is not a perfect square number. You want a perfect square number, so you need to rewrite it with multiplication. 2 times 10 is no good because 2 is not a perfect square and 10 is not a perfect square. However, 4 times 5, 4 is a perfect square number, so you could split the root there, and you will get the square root of 4 is a nice answer, 2. The square root of 5, you can't do it, so it comes down, and we should know that the square root of -1 is equal to I, so that guy comes down as I. So what I really have here is I times 2 times the square root of 5, and the only other thing we could do is put it in order, 2I square root of 5. And when we check our answer here, we will see multiple choice. Where is it at? There you go. 2I square root of 5 is the correct answer for question number 19. In this question, we have the square root of -25 with the negative in the front. Now, the number one mistake students make is sometimes when they see a negative and a negative, they want to change to plus positive. That only works if you actually have minus the negative, and this is not minus a negative. This is minus the square root of -25. So this is a negative in front of the square root of -25. You have to do the square root of -25 first. Okay, so we should know that -25 is really a -1 times 25. And you could split the root, -1 times 25. And you could do the square root of -1. What's the square root of -1? That's I. And what is the square root of 25? That's 5. So I really have I times 5, which is 5I. Now, what about this negative right here? You need to bring that negative down. Again, we are bringing the negative down. And there's your final answer, -5I. -5I. We take a look at our answer. That's what you need to type in, -5I. So right here, we need to select all the true statements, and whoops, I forgot to cover this one up. Obviously, there are some of these that are correct. It's not that none of these are correct. I mean, that could happen on the quiz, but right here, there's at least one correct. So let's think about this. We have the negative sign in front of the square root of 4. So we need to think, what is the square root of 4? The square root of 4, what number times itself? 2 times gives you the answer 4. That will be 2. And of course, you're going to put a negative in front. So there's the 2, then you take the negative and you put it in front. There's your answer. That is a true statement. So that's why it's green right there. Let's look at this one right here. We know that the square root of -9, we should know that the square root of -9, the negative is really an I that comes out, right? So you could do like this. You could write it 2I times the square root of regular positive 9. What is the square root of 9? That's 3. So what I really have here is 2I times 3, which is really a 6I. And obviously that is not a 6I, so this is false, right? Let me show you. That has a red circle on it. It's not true. Moving on to the next one. Again, right here we have a square root of -4. So you should know that the negative comes out, it's I, and the square root of 4 is 2. So you really have the negative sign out in front. This negative sign, it comes out and it becomes an I. And when you look at the square root of 4, that becomes a regular 2. So you really have -I times 2. The answer is -2I. That's exactly what we have here, which means that this one is true. Last but not least, when you have a square root on a fraction, what you need to do is split that root. So you're going to put the root on the 16, put the root on the 144.
So it's like having two problems. What is the square root of 16? That's 4. What's the square root of 144? That's 12. So the question is, whenever you have a fraction as an answer, the question is, could you reduce it? And in this case, yeah, you could reduce both top and bottom by 4, and that'll give you 1 up on top, 3 on the bottom, and that's exactly what it is, which means that that is correct as well. So you select these 3, 1, 2, 3, and then you hit submit, and that should give you full credit. Number 22, the square root of 98. Okay, anytime we want to simplify the square root of a number, you want a perfect square number list. And once again, how do you make that list? Just go 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100, and you could keep going as far as you want. Now, because this number is 98, I'm not going to go past 98. Well, I already did. I went to 100. But anyways, this is a list of all the numbers, perfect square numbers, that I could use for this square root of 98. Now, again, 98 is not up here. 98 is not a perfect square number. I wish this said the square root of 81. That would be easy. The answer is 9. But it's not the square root of 81. It's the square root of 98. So the question is, could I rewrite 98 with multiplication to obtain one of these perfect square numbers? Now, maybe 98 is divisible by 4, and I could do like 4 times a huge number that'll give me 98, and then I could split the root, and I could actually do the square root of 4. But that's not productive. What I always say is, my advice to you is, think of or use the highest perfect square number possible. So yeah, maybe 4 works. Will 9 work? No, it won't. 9 times 11 is 99. Will 16 work? Maybe. How about 25? How about 36? How about 49? 49 times 2. 49 times 2 is 98. So don't go with the first perfect square number that works. Go with the highest perfect square number that works. And of course, you could use a calculator. You could say like 49 divided by, or 98 divided by 49. You'll see that it'll equal 2. So we're going to rewrite that as 49 times 2. And we're going to split the root. And of course, the square root of 49 is 7. And the square root of 2 stays the square root of 2. So your final answer that you should type in is 7 square root of 2. Number 23, the square root of negative 15. The square root of negative 15. Okay, well, what do we know? We know that the negative signs are going to come out as I. Okay, now if you forgot that, let me show my work here. Negative 15, the whole number negative 15, that's really a negative 1 times 15. And when we split the root, yeah, that square root of negative 1, that becomes the variable I, which means imaginary. And then you got to attempt to break down 15 to get a perfect square number. Like if this were 16, the square root of 16 is just 4, it would be 4i your answer, but that's not 16, that's 15. So the question is, could you rewrite it with multiplication to get a perfect square number? And if you rewrote 15 as 3 times 5, neither of those are perfect square numbers. So it's pointless to break it down to 3 times 5. In other words, you're just going to leave it the square root of 15. So your answer is I square root of 15. And as you could see, none of these is the correct answer. I square root of 15. Moving on. Another pretty easy question. Whenever you have a square root of a fraction, simply split the root to the numerator and to the denominator. And you should be comfortable because these are both perfect square numbers, right? You could do the square root of 49, you could do the square root of 81. The square root of 49 is 7, and the square root of 81 is 9. And always try to reduce your fraction, but you can't reduce 7/9, so that is your answer. Simply type that in as a fraction, 7/9, and you will get full credit. Moving on to the last question. Same as the previous question, we have the square root of a fraction, and once again, we are going to split the root, put the square root of 9 up on top and the square root of 10 on the bottom. And of course, we could do the top. The square root of 9 is 3, but the bottom, the square root of 10, we can't actually do that. And you're supposed to attempt to rewrite it with multiplication to get a perfect square number, but 2 and 5, neither of those are perfect square numbers, so you cannot break it down, you can't simplify it. The square root of 10 is as simple as it gets, so it's going to stay like that. However, we know that you cannot leave a square root in the denominator. We cannot leave a square root in the denominator. So what we have to do is multiply by that exact square root value. Multiply by the square root of 10, And what you do to the bottom, you do to the top, multiply by the square root of 10. So up on top, we end up with 3 times the square root of 10. You just write it together. And on the bottom, the square root of 10 times the square root of 10, that's really the square root of 100, and the square root of 100 takes you back to the number 10. I hope you remember that whenever you have like the square root of 13 times square root of 13, that just equals 13. Or the square root of 7 times square root of 7, that just equals 7. Whenever you multiply a square root value with itself, the square root disappears and you're left with just the value that was on the inside of the square root that you started with. Anyways, again, right here, you're supposed to try to simplify 3/10. You can't reduce that, so that is your final answer right there. 3 square root of 10 over the number 10. No more square root in the bottom. All right, guys, I hope these videos help, and good luck on the quiz.